should have we're live. Great, you can hear them retards in the background. Okay, the sound sounds good. I don't hear any repeats or reverberations, and that is a good thing. And Katasha, how are you? Okay. Mechanical comprehension. Okay. Okay, one question concerns pulleys. And my audio check is done, so I don't need to listen to the time delay. All right. This one's going to deal with pulley systems. And so we have £100 on this pulley system. We have two pulleys here. We have a fixed pulley and we have a movable, what we call a fixed block and a movable block. And what I always recommend is you count the number of lines in the system with the horizontal line test. When you do the horizontal line test, you note that we have 2 ropes that connect with our horizontal line. So this gives us a mechanical advantage of 2. And think of a mechanical advantage as like a multiplier. Yes, it is, Tough Gang. All military aptitude, ASVAB, AFOQT, the SIFT, ASTV, I think I said that, and the OAR. So it's everything. So, and you will see something like this as well. So we have a pulley system. You do not count the pull rope. So this is the actual rope that the person is going to be pulling on. You do not count that rope. You do your horizontal line test. You contact 2 ropes or chains in this pulley system. And then we realize that our mechanical advantage is 2. So this mechanical advantage, it multiplies the force that we're going to apply. So if we thought to ourselves, how much weight do we need to pull 100 pounds in this pulley system? Well, since mechanical advantage is 2, which is our multiplier, we only need to use 50 pounds of pull. 50 pounds to pull this 100 pound weight. So now that you know that, everybody in the room that's participating, I'd like you to tell me how much, if this was 300 pounds and we have this pulley system, how much weight, how much pull or effort will we need to apply to this pulley system in order to raise the 350 or 300 pound weight? And you can type it in the message board. Okay, Katasha's by herself? Nobody else? Don't be shy, and please state your location and test you're preparing for. I assume Tough Gang is taking the FOQT. Deborah's taking the FOQT. Katasha's taking the OAR. There's still a couple more people in the room. And if you could hit the like button if I answered your question. If you do have questions, please send them to stemwithkino@gmail.com. All right, ASVAB. What branch are you trying to get into, Tough Gang? And please note, you can also take a picture of the question in your book and send it to my email at stemwithkino.com. Stemwithkino@gmail.com, sorry. I was going to join the airport, but it's too expensive. Wow. I didn't know any money was required. But, okay. All right. Katasha, I'll do another mechanical advantage one. This question is going to concern. Do I want to do that one? That was the correct answer, Katasha. Good job. That was the correct answer. Okay, another mechanical comprehension question coming right up. So, if you've been looking at some of my videos, one of my videos concerns lever or lever systems. Basically, a lot of questions will be concerning the Class 1 lever system. Okay, so we have something called a fulcrum. And all you guys, we were all kids at one point. And we played on a seesaw. So that is the closest representation to the Class 1 lever system, or lever system. So basically, a lot of times, and a lot of questions, what you'll be asked, we have a person here, and we have a person here. And let's say they're 200 pounds each. And let's say that they are 4 feet away from the fulcrum. Oh, forgot my 4. Okay. Now, typically, we look at one of these loads. We look at one of these as a load, and the other one as an effort. I'll just label them L and E. So one's a load, one's an effort. It doesn't matter, they're interchangeable. This could have been an effort, that could have been the load. The most important thing is you have to understand is that a load moment is being produced by both of these objects being set a certain distance away. So the load moment, L-O-A-D, moment, is a function of the weight and the distance away from the fulcrum, which is here. And I like to think of the fulcrum as an equal sign, because if we're going to have balance, then the load moments have to equal out each other. So this would be 200 pounds times 4 feet, or 800 foot-pounds. And on this side, we have 200 pounds times 4 feet. And this would also be producing 800 foot-pounds. So at the end of the day, they are exerting the same load moment. This load moment is 800 foot-pounds. This load moment is 800 foot-pounds. So now I have a question. And the question is as follows. I'll just start all over. I'll draw it out, because I think one of you guys don't have audio. So I'm going to draw it, Remember, this is the fulcrum, so we look at that as an equal sign. All right, so we have 80 pounds, and it doesn't all, it could be your arm, it could be your hand. This is my representation of an arm. Here's a shoulder. All right, so it could be your hand pulling down 80 pounds of force. Now, let's just say that this block is 1 foot away from the fulcrum, and this is 4 feet away. The point where we're pulling down is 4 feet away from the fulcrum. Okay. So what we have is, normally you will have 2 pieces of information on one side. All right, let me get organized here, folks. So normally you're going to have 2 pieces of information on one side of the fulcrum. All right. So when we look at this, can anybody tell me what the load moment is? Just type it in if you can see it. I'll wait a minute. If we can see the load moment on this side. Remember, load moment is a function of weight and distance. And don't be afraid to type in the answer. It's something times something else. Okay, no entries. Well, the load moment is the weight times the distance. So 80 times 40. Now, I wouldn't even, a lot of people they'll do this. They'll say 80 times 4. I wouldn't do that. I would say 8 times 4 is 32, and then add the 0, 320. So on this side, and let me write it in a different color, 320 foot-pounds is the load moment on this side. Now remember, the fulcrum is the equal sign. So what the question is asking is, what is the question asking, folks? The question states, a pry bar is used to move a concrete block, this being a concrete block. A force of 80 pounds is applied, as shown, and they want to know what tipping force would be required, or would it use to move this concrete block. And my answers are A, 80, B, 240, and C, 320. Okay, guys, so if you see it, I'll give you 60 seconds. If you see it, can you guys tell me what is the tipping force that this person will produce pulling out 80 pounds being 4 feet away? Is it 80? Is it 240? Or is it 320? Okay. Somebody type in something. Type in A, B, or C, or 80, or 240, or 320. And if you don't think you know, just say, I don't know. Okay, 320. The tipping force is going to be 320 because, like I said, the load moments on each side of the fulcrum here have to balance out. So this is 80 times 4, which is 320 foot-pounds. And so we'll have 320 pounds. That will be the tipping force. 320 times 1 is 320 foot-pounds on this side, and the exerting 80 pounds at 4 feet is also going to be 320 foot-pounds. Good job, Katasha. You selected C. All right. I got an email. And the email that I have is, what are the 4 forces of flight? It is a SIFT, a United States Army SIFT question. There are 4 basic forces of flight. All right, I'm going to draw my little airplane. All right, there are 4 basic forces of flight. We have a vertical or an upward force called lift that's being produced by the wings. We have the weight of the aircraft, and this is caused by gravity. We have a forward vector or force called thrust, and we have a rearward called drag. So those are the 4 forces of flight: thrust, lift, weight, and drag. And another thing you need to know is, when are all these forces in balance? All these forces are balanced out in unaccelerated flight, which, if the plane was moving at a constant speed of 300 miles per hour, not speeding up, not slowing down, just at a constant speed of 300 miles per hour, then all 4 of these forces are in equilibrium or balance. See the next question. Okay, this is an aviation selection test battery question, and the question is asking, and just so you know, some people may not even be here in the room, but they will email me questions because this is being recorded. So, as these questions, if you guys don't type any questions on the message board, then I'm just going to go ahead and go to the emailed questions. All right. So the next question is from Dave in Texas, San Antonio. All right. Dave is asking, what is the difference between absolute altitude and indicated altitude? Well, you have a bunch of different altitudes, and I'll keep my little airplane there. Absolute altitude is what we would call, okay, let's get another color here. All right, let's just say we have the sea level here. This is where the sea is. But then we'll have terrain that comes up and mountainous areas and stuff like that. Now the sea level is right here. So where I am in New Jersey, I'm like the ground level is 213 feet above sea level. Okay, so the sea level is down here, and where I'm at is 213 feet above sea level. Now, one of the questions was absolute altitude. When we think of absolute altitude, it's what we would call AGL. AGL, and AGL simply means above ground level. So if I was at 213 feet, boom, the airplane at this point where the airplane is flying over me, all right, would be the absolute altitude, but that is measured from the ground level. Remember, AGL, above ground level. Now, this would be a whole different altitude above sea level. All right, and altitude measure here is what we call MSL, or mean sea level. Indicated altitude is just what you read on the gauge. As you have your airspeed indicator registering, it's the altitude that you see directly on the gauge. That's what indicated altitude is. All right, so Dave, San Antonio, thanks for sending out that question. All right. Okay. Okay, checking email. Getting a lot of emails, and people that are here, type in questions. If you have questions, go ahead and type them in. All right, the next question comes from Keisha. Keisha is in Sacramento, California. She did not indicate where or what test. But Keisha from Sacramento is asking about Bernoulli's principle. Bernoulli's principle deals with liquids or air. Air and liquids, they kind of behave the same. And Bernoulli's principle states that as the velocity of a fluid increases, its internal pressure increases. So fluid and air, they act the same way. How we demonstrate Bernoulli's principle is we use something or a device called a Venturi tube. Now, Venturi tube, let's just give you, we'd have a regular tube like that looks like a straw. That's a stream tube. But in a Venturi tube, we actually have a constriction in the middle, or it's kind of squeezed in the middle. All right. So stream tube, Venturi tube. Now, if we take meters to measure velocity and pressure, I'll just put VP. That's what this gauge is reading. It's reading the velocity and it's reading the pressure. All right. So, right, another VP there. We're measuring velocity and pressure at the beginning, for velocity and pressure at the constriction or the squeezed in part, and velocity and pressure at the other side. And what you'll notice in this Venturi tube, and this could come up on the mechanical comprehension, not just the aviation. Let's say at this point, the velocity is 100 miles per hour. And the pressure is, I don't know, 14 PSI. That's what this gauge is reading at the beginning. At this point, let's call it point B and this point C, and we'll call this point A. So at point A, you're going to have 100 miles an hour, 14 pounds per square inch in pressure. In the middle, the air molecules are actually going to speed up this part, hence Bernoulli's principle. As the velocity of a fluid increases, its pressure decreases. So this part is going to speed up to 130 miles per hour, and let's say it will drop to 7 psi. Now these are exaggerated numbers, but I just want you to see the transition. And then when we get back to C, it's going to slow back down to 100 miles per hour and come back to 14 psi. All right, so you can see the transition from A to B to C and what the meters will possibly read. You'll have 100 miles an hour of air coming in. The pressure's a little bit high. Then when it gets to the constriction of the tube, always look at it like this. I used to tell my students in flight when I was teaching, a full-time flight instructor, I'd say this is the hallway and this is the cafeteria. And there's a door in between the hallway and the cafeteria. And I would always say, well, all the students are going to speed up when they get to the door because they're trying to get in to eat. Okay. Evaluate the expression. Absolute value 3xy. Okay, we'll get to that in a sec. All right. So, Keisha in Sacramento, that is Bernoulli's principle. As the velocity of a fluid increases, its internal pressure decreases. So as the velocity of the fluid, and air and water act the same way, so we can consider or think of air like a fluid. As the velocity increases, its internal pressure decreases. So we're at 100 miles, we increase here, we go back to normal. Pressure is 14 or normal. Pressure drops, the internal pressure decreases, and then it goes back to normal. Now, what's this have to do with flying? Well, the air properties act the same at this constriction as it does on a wing. And if we looked at a airplane wing from a side view, we could fit what we would call an airfoil. An airfoil is a device used to produce lift. Or a wing. A wing is an airfoil. All right. So that's why we study Bernoulli's principle. And we need to see why, that is important. Okay. Okay, before we get to that one, Katasha, I'm going to visit a math problem that a lot of people are having issues with. All right, let's see. You. I probably can do it right off the top of my head. Okay, it's 1 minus 1 minus 1/4 1 plus 1 minus 1/4 over 1. Okay. So now, a lot of people have been having issues with this problem, evaluating this expression. Okay, it's really not as bad as it looks. A lot of people, they look at it like, oh my God, that looks crazy. Because number one, they don't like fractions. And then so you got a fraction within a fraction. So then they really kind of lose their cool. The first thing all we really need to do is we need to deal with this portion. All right. So, how we deal with this, 1 is a whole number is really 1 over 1, or we could just consider it 1. Or you can look at it as quarters. When we look at quarters, you can look at it as 4 over 4. 4 over 4 is still equal to 1. So if we use 4 over 4 minus 1/4, we'll wind up with 3 over 4 for this portion only. Okay. So we have 3/4 at this point. So it's 1 plus 3/4. If we add the 3/4 here, then this will become 1 3/4. Now at this point, what I would do is I would change this to a improper fraction. Just because to me, in my mind, it just simplifies it. So this would be for 7/4. The 1 3/4. So then after that, what we actually have is a division problem. So it will be 1 over 1 divided by 7 over 4. But when we have fractions like this is actually a multiplication problem. So what we need to do is multiply by the reciprocal. And so that would turn the question into 1 over 1 times 4 over 7. And the final answer is 4 over 7. Okay, so that is the final question. And if it looked like it went a little bit fast, this is being recorded and it's DVRable, so you can see it. Okay, welcome back, Deborah. And if you have questions, send them to stemwithkino@gmail.com. All right. So we're going to analyze or look at evaluating the expression. Okay, evaluate the expression. The absolute value of 3x minus y plus the absolute value of 2y minus x if x is -4 and y is -1. Okay. It's like, okay. I sound like Chris Brown. Okay. All right. So, absolute value 3 x minus y plus the absolute value of 2y minus x. And in this case, x is going to be -4 and y is going to be -1. Okay, Deborah, not Deborah, Katasha, what are my options? Give me the A, B, C, and D. Please. If you don't mind. I have another screen. I'm not crazy. I have another screen that I'm looking at. This actual camera is actually doing the live stream portion, and then I have another monitor. It's where I look at the questions, so I'm not crazy. Just kind of talking to y'all, and I have to look at the questions. A is 11. Is A 11 or is A -11? Well, that's wrong anyway because these are absolute values and they can't be negative. So I just need to know if that's -11 or just 11 by itself. Actually, okay, you got the little parentheses there. So -11. That's wrong. It can't be -11 because these are absolute values. Everything encompassed in the negative and the absolute value symbols are going to wind up being a positive number. Okay, what's B and C? Okay, B11, C13, D -13. A -11, B11, C13, D -13. It can only be B or C, first off. Because like I said, these are absolute value problems. Everything's encompassed in absolute value. So now what I will do is I'll bring this down. 3, -4, and the Y. Ooh, hold on, Kino. Minus Y, which is -1. That's encompassed in the absolute value. And then 2y, -1, minus -4, which is x. All right. So it's this plus this is basically this plus this. So as I look at this, the first thing I'm going to do is I'm going to deal with the negative and the negative. This is going to make this a +1. All right. And this is going to make this a -12. Now, normally what would happen, -12 and +1 would turn out to be -11 for our first part. So I just put this up here, -11. But it's encompassed in the absolute value. So that's where we got to be careful. This negative distributes in here and becomes +4. And the 2 and the 1 merge or multiplication becomes -2. And this would be the -2, +4, which would be +2. All right. So when I look at this, just because it's considered absolute value, we do not look at them as negatives. We just look at them as positives. So 11 plus 12 is 13. All right. 11 plus 12 is 13. Your answer is Charlie. C is in Charlie. Because you have to understand that absolute value. Absolute value only cares about movement, the distance traveled, or units traveled on a number line. They don't care about negative. and they're always positive when they're encompassed in the absolute value. So even though we have a negative 11 there, it's encompassed in absolute value, and it's talking about total units moved. So this is 11 total units moved plus 2 units moved, and that would be 13. So it doesn't deal with positive and negative, really. It throws that rule out when we encompass it in negative and absolute value. And type in clear if you got that, guys. And let me check the email. Okay. Very good. I'm getting some similar questions here. I'm trying to look at one that is a little bit different. For military aptitude test prep questions, I cannot overstress the value of understanding a 3-4-5 triangle. If everybody understands the 3-4-5 triangle, please type in yes. It's only a couple people in, so I mean, Deborah understands. Katasha, do you understand the 3-4-5 triangle? Yeah. Okay, great. All right. Trying to think of something else. Okay. Okay, nothing on the message board here. So, Julian from Long Island. Okay, next door neighbor in New York. Okay. Julian is asking the difference between a nautical mile and a statute mile. That's a good question. 1 mile. You're driving down the road, and it says exit 1 mile. Well, 1 mile is equal to 5,280 feet. But what kind of mile is that? This kind of mile, your car mile, is called a statute mile. Statute. Is there another T in there? I don't want to, because y'all talk about me if I don't give y'all the right information. Hold on. Let me Google. Statute mile. I'm Googling. Alright. Just want to make sure I am statute. Okay. But you're not telling me. Yeah, statute mile. So there is a T in the middle. Just wanted to make sure. STATUTE. A statute mile. A statute mile is what we're all familiar with. When they say how long is a mile, it's 5,280 feet. And boats and airplanes use something called nautical miles. Air and naval vehicles. All right. Air and naval vehicles, when they say 1 mile, they are talking about a statute mile. And a statute mile is 6,076 feet. All right. This is a nautical mile. Okay. And it is important to understand that the nautical mile is 15% more. So if we had 1 mile nautical, this would be 1.15. All right. 1 nautical mile is equal to 1.15 statute or car miles. All right. So that's the difference, Julian. All right. I hope that answered your question. A car mile, 5,280 feet. That's a statute mile. An air mile or boat mile or a nautical mile is 6,076 feet. And if you have 1 nautical mile, it's actually 1.15 statute miles. Okay. All right. Let me check the message board, make sure there are no questions from the people that are in attendance. I sent you a request on Skype bot. Okay. I think. Okay. Or if you have a Gmail account, we can video conference like that as well. So no worries. And if you email me, okay, cool. So yeah, if you got the Gmail account, you're fine. You don't necessarily need Skype. I like Skype because Skype kind of records all your progress. Okay. I hope you're ready. AFOQT is really not that bad, I don't think. I think the ASTB, E, and the OAR are the hardest. They're harder than the AFOQT. For information, you got verbal analogies, arithmetic reasoning, word knowledge, math knowledge, instrument comprehension, which won't weigh heavy if you're not trying to be a pilot. Block counting won't. Table reading may. General science, I don't think that's weighted. And you may have rotating blocks or hidden figures. I think they took hidden figures off. Okay, but good luck to you. And I definitely would like to have a conversation with you. All right. You feel way more ready than before. Well, that's good. I hope I had something to do with that. Thanks, baby, too. I took the test, so I'm familiar with the format. What do you want to read? Wednesday, Thursdays, Fridays, and Saturday mornings. All right. When I took the AFOQT, it was almost fun, but I'm going Army now. Okay. You will be sorry. I'm joking. Air Force, I gotta, stand up for my team. I don't know. There's been a couple times when I had to kind of hang out on an Army base. Test. Okay, good luck, y'all. I test 5th of September for the Navy. Okay. Yeah, my experience, I think one time we were just kind of on an Army base for a little bit, and so we were going to the mess hall. And the mess hall, we were used to the Air Force mess hall, or the Navy mess hall. We're like, oh man. We went to the Army mess hall, and I'm pretty sure that it's changed by now. I'm old, so this is back in the day. But, yeah, I'm pretty sure the Army stepped their game up. All right, I almost got PDQ for peanuts, but now I can eat them. I'm already going Army. Okay. All right. Okay. Okay, so we have reached our hour. I don't see anybody in the... I'm just looking for current people that are... Okay. I don't see anybody that is a client of mine. So, yeah, I guess this is just it, guys. Please hit the like button if you did enjoy this live stream. No problem, Viper. The Google chat, the Google Hangout is pretty much client based only now. My team has really been like kind of on me about that. So yeah, so I don't see any emails from any current clients, and everybody here is pretty much live stream people. So I'm going to check my other email though, just in case. But I really, really appreciate you guys coming out and asking questions and stuff like that. And for future reference, one-on-one tutoring is available via Skype, or you could do a Google Hangout. Not a problem. And also my API prep for naval aviators and Air Force aviators, wannabes. There is a API aviation pre-flight indoctrination and UPT undergraduate pilot training prep course that I've started. There's a video, and that went really, really well. Okay, Kadasha, it went really, really well, and the API UPT prep is if you're a pilot, you're going to see all this information. There's a wealth of information that I have, and so it's better to just get on it now. But this is after you pass your test. I don't want anybody, calling me or emailing me about API or UPT prep and you still haven't taken your ASTB, AFOQT, or your OAR. I don't want anybody. Did you take the test? No, I didn't take the test yet. No, that's the first milestone that you need to get over. Then API or undergraduate pilot training, and even before undergraduate pilot training, you have initial flight screening and stuff like that. I prep for that. SIFT. I do SIFT prep as well. And so the cool thing too is I have simulators available where you could virtually get in a cockpit with me just from the comfort of your home and laptop, and then we could actually go through the panels and systems and all that and everything. Wait, I knew that answer. Okay, so, all right. I hope you guys are around next week. Feel free to jump in and come to the live stream. I welcome you guys all for showing up. Take it easy.